Welcome back, everybody. Going to cover another article today. The case of the cosmic wanderer, a supermassive black hole caught out of place. Not all that wander are lost, but some black holes, well, we're going to talk about it. In this image, you can see a color image of AT 2024 TVD from the Hubble Space Telescope and the James Webb Space Telescope. The yellow dot inside the square marks this galaxy's center. Well, the TDE is a white dot which is visibly offset to the upper left about 2,600 light years away from us. And in the vast architecture of the universe, most supermassive black holes, SMBHs, are homebodies. They sit at a gravitational hearts of their galaxies, growing fat on gas and dust. But astronomers have just discovered something that breaks these rules. It's a supermassive black hole caught wandering far from the center of its galaxy, announced by a violent destruction of a nearby star. What is AT 2024 TVD, which I showed you up above? The event, dubbed AT 2024 TVD, is a tidal disruption event, a TDE. This occurs when a star wanders too close to a black hole. The black hole's immense gravity pulls harder on the near side of the star than the far side, and that process is called spaghettification, shredding the star into streams of gas. As this debris swirls into the black hole, it heats up and releases a massive flare of light across the electromagnetic spectrum. While TDEs are rare, what makes AT 2024 TVD truly bizarre is its location. It was spotted roughly 2,600 light years, 0.8 kiloparsecs, away from the center of a massive galaxy located 600 million light years from Earth. To understand what was happening, the study's authors had to weigh the culprit. Since you can't pull a black hole on a scale, they used a model called the Kerr-SED. By looking at the plateau phase, a period after the initial flare, when the light comes directly from the accretion disk, the researchers analyzed the temperature and brightness of the debris. A more massive black hole produces a larger, cooler disk, while a smaller one produces a hotter disk. The result? The black hole has a mass of about 1 million suns. This officially places it in the supermassive category rather than the smaller intermediate mass category, usually associated with displaced black holes. So why is it wandering? Well, usually we find a black hole away from a galactic center. It's tucked inside a small satellite galaxy orbiting the larger one. However, deep imaging of AT 2024 TVD's location revealed nothing. There was no star cluster and no small galaxy around. This suggests that this black hole is a true wanderer. It's likely belonged to a smaller galaxy that merged with the larger host galaxy long ago. During that merger, the smaller galaxy was stripped of its gas and stars by tidal forces, leaving the central black hole naked and slowly sinking toward the new galactic center. Why does it matter? Well, the discovery of AT 2024 TVD is a game changer for several reasons. First, it expands the off-nuclear catalog. Previously displaced TDEs were only linked to intermediate mass black holes in small star clusters. This proves that full-blown supermassive black holes can be found roaming the outskirts of galaxies. Extreme ratios. The ratio of the black hole's mass to the stars surrounding it is over 3%, which is much higher than typical galaxies. This is a smoking gun for a black hole that has lost its original stellar home. Galaxy evolution provides direct evidence of how galaxies grow through mergers, showing us the leftovers of cosmic collisions that happened millions of years ago. Bottom line, AT 2024 TVD reminds us the universe is messier than our models often suggest. Not every giant black hole stays in its lane. Some are cosmic nomads, only revealing their presence when they stop for a final violent meal. There's the source. It came out of the Astrobytes article. If you're unfamiliar with Astrobytes, Google them. Great postgrads and undergrads that are posting articles and reviews of articles that they have. Highly recommend it. One of my great sources. Thanks for joining me. We'll catch you next time.